Hey everyone, it's Justin again. I'm so glad we started playing Power Play. It's just full of so many surprises, like the secret radical beach levels we unlocked in the last lesson. Last time we learned to surf our first wave by calculating the square roots of perfect squares and estimating the square roots of non-perfect squares. But this next level, it's all about big wave surfing. Big wave surfing is like the ultimate thrill ride of the ocean. Picture yourself charging down monstrous, towering waves, some taller than buildings. Being able to estimate square roots is a helpful skill for everyday tasks, but they are just that, an estimate, which means they aren't precise. To safely surf these massive waves, our precision must be on point. So rather than estimating square roots, today we'll learn how to simplify them instead. What are we waiting for? Let's power up Power Play and head over to Radical Beach.
Warning, high surf. To surf the big wave beach, you must be able to simplify square roots.
We haven't found a challenge we couldn't master yet, so let's do this. Password? I don't think I know the password. Let's try this help button. Ooh, another discovery type activity. I love these. It says to consider the examples below and fill in the missing information. We'll need some time to think about this, so go ahead and pause here to analyze the information in your guided notes and try to fill in the blanks yourself. We'll discuss when you're done. Were you able to fill in the blanks? Starting with the first line, we have the square root of 16 equals the square root of 4 times 4. Do you have any idea where that 4 times 4 came from? Well, 4 times 4 equals 16, so it's just a factored version of the original radicand. From there, it appears the one radical has now split into 2, giving us the square root of 4 times the square root of 4. It's important to note that there are equal signs between each of these expressions, which means they're all equivalent to each other. The two rows below are following this same pattern. If you were stuck before, pause now to try again. In the second row, we have the square root of 100 equals the square root of 25 times blank. What do you think should go in the blank? In the row above, we determined that the expression under the second radical was a factored form of the original radicand. So for the second row, we need to determine what factor times 25 equals 100. 25 times 4 is 100, so that would make this next equivalent expression the square root of 25 times the square root of 4. Now, what about that last row? We've got some variables this time. The square root of AB equals the square root of what times what? Well, two variables next to each other means they're multiplying. So we could just rewrite them with the multiplication dot, and now we have the square root of A times B. Then this one radical can split into 2, giving us the square root of A times the square root of B. Whoa! We discovered a radical rule. A radical, like the square root of AB, can be rewritten as the product of two radicals, the square root of A times the square root of B. Let's test it out. If this rule is true, then each side of these equations should be equivalent. To keep things less complicated, let's just focus on the positive square roots right now. Go ahead and pause here to evaluate the positive square roots of each side of the equations below. The positive square root of 16 is 4, And on the other side, the square root of 4 is 2, giving us 2 times 2 which equals 4. And in the next equation, the square root of 100 is 10. And on the other side of the equation, the square root of 25 is 5, and the square root of 4 is 2. And 5 times 2 is 10. The rule works. And I think it might be the password we need. We still need to learn how to simplify square roots, but now we have that radical rule in our tool belt to help. A radical is considered simplified when the radicand has been made as small as possible. The examples we just completed were all perfect squares, so we were able to fully evaluate the radical. But how do you think this works with non-perfect squares? Let's consider the square root of 12. 12 is a non-perfect square, so we won't be able to fully evaluate it. But the radical rule should be able to help us simplify it. So the radicand is as small as possible. The radical rule tells us we can rewrite the square root of 12 as a product of radicals. So what are the factors of 12? To get 12, we could multiply 1 times 12, 2 times 6, or 3 times 4. But which one of these options is going to help us simplify? Take a moment to pause here and think about each of these options. With your perfect squares list in mind, try to identify which one will help us to simplify. When simplifying square roots, in order to keep things as simple as possible, we only need to focus on the positive roots. So in this first one, 1 is a perfect square, so we could simplify the square root of 1 to 1, which would leave us with 1 times the square root of 12, which simplifies further to the square root of 12. That's what we were trying to simplify, so that one was not helpful. In the second one, neither 2 nor 6 are perfect squares, so rewriting the square root of 12 as the square root of 2 times the square root of 6 actually made it even less simplified than before. Another dud. But how about the third option? 3 is not a perfect square, but 4 certainly is. The positive square root of 4 is 2, giving us the square root of 3 times 2, which could be rewritten with 2 as a coefficient in front of the square root symbol. The radicand, 3, is now as small as we can make it, so the radical is simplified. To simplify radicals, we can split the radicand into factors, but we need to be intentional about which factors we choose. Like we saw with this example, the helpful factor set included a perfect square that wasn't 1. Let's try it again. We need to simplify the square root of 80. Does 80 have any factors that are perfect squares? Yeah, 4. We can rewrite this as the square root of 4 times the square root of 20. The square root of 4 is 2, making our new expression 2 times the square root of 20. But this radical isn't fully simplified yet. Can you identify why? 20 also has a factor of 4, which is a perfect square. Since 4 times 5 is 20, we can rewrite this again as 2 times the square root of 4 times the square root of 5. Don't forget to include that constant of 2 in front of the radicals. What do you think we should do next? Since 4 is a perfect square, we can simplify this further to 2 times 2 times the square root of 5. Could the square root of 5 be simplified any further? 5 is not a perfect square, and it doesn't have any factors that are perfect squares, so it is already simplified as much as possible. But these 2's multiplying in front of the radical can be simplified. They need to be multiplied together, resulting in our final simplified answer of 4 square root of 5. You may have noticed that in our original radicand, 80, it had another perfect square factor, 16. So we could have started by rewriting the expression with the factors 16 and 5, which would further simplify to 4 square root of 5, which is the same answer. The only difference is that this way started with the largest perfect square factor of 80. It'll be more efficient to get to the fully simplified version if you use the largest perfect square factor right away. But if you don't notice it, it's still okay. If you keep factoring the radicand until it's as small as possible, you will still end up with the same answer. Why don't you try this next one by yourself? Pause here to simplify 2 times the square root of 72. 72 can be rewritten with perfect square factors several ways, but I chose to rewrite the expression using the factors 9 and 8 as 2 times the square root of 9 times the square root of 8. 9 is a perfect square, so the square root of 9 can be simplified to 3. 8 has a perfect square factor of 4, so the square root of 8 can be rewritten as the square root of 4 times the square root of 2. Then the square root of 4 can be simplified to 2. Can the square root of 2 be simplified any further? Nope. So all that's left to do is multiply all of these constants together, giving us our final answer of 12 square root of 2. Here are the other ways you could have simplified this problem. This option on the right has fewer steps than the others. Why do you think that is? If we look at the perfect square factors used in the first step of each of these, we can see that 36 was the largest, which explains why that option was the most efficient. But remember, as long as you keep simplifying the radicand until it's as small as possible, you'll still get the correct answer no matter which perfect square factor you start with. Feel free to pause here if you need more time to check your work. Now that we've learned how to simplify square roots, do you think we are ready to take on a wave at the big wave beach? There's only one way to find out. Whoa, that's one big wave. We need to be as precise as possible. So pause here, take your time, and simplify 4 times the square root of 108 in your guided notes. The first step is to identify a set of factors of 108 that include a perfect square. 108 has a few different factors that are perfect squares. 4 times 27 equals 108, so if you use those factors, your work may look something like this. Or maybe you found that the perfect square 9 is a factor of 108. 9 times 12 equals 108, so in that case, your work may have looked something like this. You may have even noticed that 4 and 9 are perfect square factors, and 4 times 9 is 36, which means that 36 is also a perfect square factor of 108. You only needed to start with one of these options to get to the answer, but here's all the possibilities. As long as you keep factoring the radicand until it doesn't have any more perfect square factors, then you will reach the simplified answer. Pause here if you need to compare your work with the work displayed on screen. And once you're ready, we'll input our answer into the game. We did it! We beat the whole game of power play, 100%! And we learned so much, like how to simplify exponent expressions using all those exponent properties, what radicals and square roots are, and how to evaluate, estimate, and simplify square roots. All that's left in this lesson is the PDF activity and the online practice. There's also an optional activity in your PDF that demonstrates an alternative way to simplify square roots. That's the end of this video, but why not one more? For old time's sake. Ready? We harnessed the power of the power! See you next time.